Hello everyone, and welcome. Some elements are valuable because they are beautiful. Others are valuable because they are useful. But a select few are valuable because they are so incredibly rare that only microscopic amounts exist anywhere on Earth. Today, we're exploring Einsteinium, one of the rarest and most expensive synthetic elements ever created. We'll discover what it is, how it was discovered, why scientists produce so little of it, and why this remarkable element continues to play an important role in modern nuclear science. Let's begin. Einsteinium is a synthetic chemical element with the symbol Es and atomic number 99. It belongs to the actinide series, a group of heavy radioactive elements located near the bottom of the periodic table. Unlike naturally occurring elements such as iron, copper, or gold, Einsteinium does not exist in useful amounts in nature. Instead, scientists create it through complex nuclear reactions inside specialized research reactors. The element was first identified in 1952 by a team of scientists studying the radioactive debris produced by the world's first hydrogen bomb test. During their analysis, they discovered atoms that had never been seen before. This remarkable discovery led to the identification of a completely new element. It was later named Einsteinium in honor of the famous physicist Albert Einstein, whose groundbreaking work transformed our understanding of physics, energy, and the nature of matter. Why is Einsteinium considered one of the most expensive elements ever created? The answer begins with how incredibly difficult it is to produce. Scientists cannot simply mine Einsteinium from the Earth. Instead, they must create it atom by atom inside powerful nuclear reactors. Heavy elements are exposed to intense streams of neutrons, allowing new and heavier atoms to form through a series of nuclear reactions. This process is extremely slow and technically demanding. After production, scientists must carefully separate tiny amounts of Einsteinium from many other radioactive elements using specialized chemical techniques. The quantities obtained are astonishingly small, often measured in micrograms rather than grams. To understand just how small that is, 1 gram contains 1 million micrograms. Only a handful of research facilities in the world have the technology and expertise required to produce this element, making every tiny sample exceptionally valuable. Although exact prices are difficult to determine because Einsteinium is not sold as a commercial product, scientists estimate that producing a gram would cost millions of dollars due to the enormous time, equipment, and expertise involved. Its value comes from the extraordinary effort required to create it, rather than from commercial demand. A common question is, why don't scientists simply produce more Einsteinium? The answer is that producing larger quantities is neither practical nor necessary. Nuclear reactors capable of creating heavy synthetic elements are extremely expensive to build and operate. Production takes months or even years, and only tiny amounts are created during each cycle. Another challenge is that Einsteinium is highly radioactive. Many of its isotopes gradually decay into other elements, meaning the material slowly changes over time. Scientists must also follow strict radiation safety procedures during production, transportation, storage, and research. Perhaps most importantly, there is very little worldwide demand. Einsteinium is not used for jewelry, electronics, or consumer products. Nearly all of it is produced specifically for scientific research. For these reasons, producing large quantities would provide little practical benefit while requiring enormous financial investment. Although most people will never encounter Einsteinium, it has made important contributions to science. Researchers use it to better understand the behavior of heavy radioactive elements and the forces that hold atomic nuclei together. Experiments involving Einsteinium have helped scientists investigate the chemistry of the actinide series and improve theoretical models of nuclear structure. The element has also played an important role in the creation of even heavier synthetic elements. By studying Einsteinium and using it in carefully designed experiments, researchers continue expanding our knowledge of the periodic table and the limits of atomic stability. While Einsteinium has very few industrial applications, its scientific value is enormous because it allows researchers to answer fundamental questions about matter itself. Because Einsteinium is highly radioactive, it must always be handled with exceptional care. Its radiation can damage living tissue, making direct handling unsafe. Scientists work with Einsteinium only inside specialized laboratories equipped with thick radiation shielding, remote-controlled instruments, and continuous monitoring systems designed to minimize radiation exposure. These strict safety measures protect researchers while allowing them to study one of the rarest elements ever produced. Here are a few fascinating facts about Einsteinium. The largest quantity ever produced at one time was only a tiny fraction of a gram. Most people will never see a visible sample of this element during their lifetime. Because it is highly radioactive, studying Einsteinium presents unique scientific challenges, requiring researchers to complete many experiments before the material changes through radioactive decay. Even after more than 70 years of research, scientists continue learning new information about this remarkable element. Einsteinium reminds us that some of the greatest scientific discoveries are not measured by size or appearance, but by the knowledge they provide. Although it exists only in microscopic quantities, this extraordinary element continues to help scientists explore the boundaries of nuclear chemistry, deepen our understanding of atomic structure, and advance research into the heaviest elements known to science. Thank you very much for watching. If you enjoyed learning about one of the rarest and most fascinating elements ever discovered, please consider giving this video a like, sharing it with others, and subscribing for more science-based content about chemistry, physics, and the amazing world of the periodic table. We truly appreciate your support, and we look forward to seeing you in the next video.